CES Selector integrates environmental and engineering data, powerful material selection and substitution capabilities, and Granta's eco-audit methodology. This enables engineers to consider the environmental impact of products and explore what-if scenarios in the early stages of design. As a general rule, 80% of a product's environmental impact is determined at the design stage. So it is important to think about eco-factors at this point, where you have the opportunity to change both your material choices and basic design, enabling you to minimize environmental impact at minimal cost. But this raises two issues. How do you find environmental data for materials you haven't considered before? And how do you identify alternative materials with lower impact that also meet the performance and economic requirements? Here we'll use an example of an automotive transmission crossbeam to demonstrate how we can quickly evaluate alternatives. We'll start by viewing the environmental data that is provided for thousands of commonly used engineering materials in the Material Universe data module. Among the dozens of properties on this datasheet for a 5000 series aluminium alloy are its ROSH compliance, energy usage and CO2 footprint for primary production and various processing techniques, and end-of-life recovery. Now let's use this data with CES Selector's Eco-Audit tool. The starting point is the bill of materials. We have specified this here. I'm going to enter the details for the main crossbeam, made from aluminium. I specify its recycled content as typical, its mass is 2 kilograms, processing method is casting, and make an assumption that 90% of components will be recycled at end of life. I can then specify the transport and use phase for my component, in this case specifying a duty cycle relating to a service life of 150,000 kilometers, a summary chart which shows the energy usage and CO2 footprint for each life phase, identifies the use phase as the dominant phase, and provides guidance on strategies for reducing its impact, in this case reducing mass whilst maintaining performance and cost requirements. Using the material selection tools in CES Selector, I can identify alternative materials. This chart, which shows a trade-off between mass per unit of strength and cost per unit of strength for a beam loaded in bending, identifies that switching from our current aluminium alloy to 50% glass-filled polyamide could lead to a weight saving of around 40%. We can estimate the impact of this weight saving by creating a new eco-audit project, specifying 50% glass-filled polyamide with 60% of the mass of the aluminium component, processed by injection molding, and, as fiber-filled polymers are not commonly recycled, sent for combustion at end of life. This identifies a 40% reduction in environmental impact over the vehicle life, but also highlights a lower potential to utilize the material in future life cycles. This combination of ready access to environmental data, eco-audit analysis, and material selection tools enables you to rapidly estimate the environmental impact of your design for its complete life cycle, identify the dominant life phase and main contributors, and quickly investigate the effectiveness of different design strategies for reducing its impact. This enables you to make well-informed decisions on how to minimize the environmental impact of your products at a stage where you can respond to the results and change both the basic design concept and the materials. If you have further questions or are interested in purchasing CES Selector, please contact us directly, explore our website, or watch other videos demonstrating further applications of CES Selector.